All right, so this is Mrs. Slauson, and now we're doing the graphing portion of the logs unit. So a couple things to remember, a little different than graphing and exponential, is that our asymptote will be a vertical asymptote. And so when you shift left or right, that will affect your original asymptote, which is traditionally with the parent function right here at y equals 0. So just keep that in mind. And as we progress through this, I'll be taking more shortcuts to get through the graphs a little bit faster. So starting on the first problem, I'm going to just take a look at the transformations. So based on what I see here, I will be going right 2 and down 5. So from there, I need to make my t-chart, and we do that by making the inverses. Okay, so I had to pause there for a moment. So first I'm going to be finding the inverse. And when I find the inverse of this log function, I will be leaving out the transformations of right 2 down 5. So the minus 2 and minus 5 are not going to play a role when I do this. So when you do a inverse of our function, the first step is you switch x and y around. And I'm also going to put the log on the left side now. And now the inverse of a log function is an exponent, so I will make my e. So it becomes 2 to the x power equals y. And 2 to the x power equals y is what I will be making my t-chart from. Okay? So in my class, if you're watching this from a different class, when we graphed exponential, used these points. Your teacher might have had to use fewer points or different points, but these were the points that we used. And one idea is you can actually just go to your 2 to the x equals y and put 0 in, put 1 in, put 2 in. But what we talked about in Mrs. Slauson's class is that where we begin, the y-intercept is 1. And then it grows by 2, taking some things that we had learned in algebra. So I just start multiplying by 2 as x gets bigger. So after 1, I'd multiply by 2 and multiply by 2. And then going the other way, I could divide by 2 and get a pretty good list of points to graph. We won't be graphing these. I mean, you can, but I'm just going to be graphing the integer points, the points that are very easy to graph. So if you remember, again, these are the points for the exponential function. I will now need to get the points for the log function, which just means I switch these x's and y's around. So the y's of 1/4 and a half and 1 and 2 and 4 will become the x's, and the x's of -2, -1, 0, 1, and 2 will become the y's. And again, I'm not going to graph these. I probably didn't even need to put them in my new t-chart, but I'm going to come over here and graph 1, 0, 2, 1, and 4, 2. And now what will happen is I will transform these points, but before I transform the points, I'm going to take a look at the original asymptote, which is along the x-axis, which is x equals 0. So it visually looks like the y-axis. So the wall will be moving to the right too. So I'm going to start there, and this is where my wall will be. So my shape will not be able to cross that. So now what I'm going to do is take all the points, and I'm going to move them right 2 and down 5. So I'm going to take 1, 0 and go right 2 and down 5. And I'll take 2, 1 and do the same thing, right 2 and down 5. And then I'll take 4, 2 and go right 2 and down 5. Now, there aren't a lot of points here, so you might want to remember that a log, as it grows, because this is growth, looks like kind of like lowercase r. So I'll just connect my points. And now we'll use this shape to answer the questions. So to answer domain range, we kind of need to look at what's happening with these arrows. So on the right, x's are getting bigger. So for this arrow, we use an infinity. And as we go to the right, the y's are also going up, which means they're getting bigger and bigger. So this arrow can be defined by infinity and infinity. Now, when I try to go to the left, which is normally a negative infinity, I can't keep going. I'm going to be stopped by the wall of 2. But as I approach 2, my y's are getting smaller, and they're going to keep going down and down. That's what the arrow means. So I'll put that for my y value. Okay? So now I'm going to use this to answer my domain, range, and behaviors and such. So in the first one, my domain is the smallest x and biggest x, so I'll put 2 and infinity. And I'm going to be using parentheses on the 2 because it's not going to reach 2. It's going to get close to 2, but it will never be 2. My range is the smallest y and the biggest y, so negative infinity and infinity. For my end behaviors, we start writing all this stuff. So x is approaching infinity. I can see that right here. So as x is approaching infinity, f of x is going to infinity. And then when we write, x is approaching negative infinity, it doesn't approach negative infinity. It approaches 2. So what will happen here is, depending on what your teacher has you do, I'll just put not applicable. And then my asymptote. Again, the original asymptote is x equals 0. But since it shifted to the right, it is now at x equals 2. All right, let's take a look at B. So B, same idea is going to happen. I'm going to take a look at the inverse. So let's start talking about some of the shortcuts. First, the transformation, based on that -1 that you see, it will be going right 1. And what we started talking about in my class is that you can actually just see the inverse if you ignore all the transformations that are going to happen. And it's right there. It's 4 to the x power. So if you see that shortcut, by all means, go ahead and take it. So this is what I'll make my exponent t-chart with. And again, in my class, we chose these points. And in this problem, b is 1, and it's growing by 4. So the y-intercept is 1, and then I can start multiplying by 4. Or go the other way and divide by 4. Again, when I graph, I won't use these because I would prefer just using the integer x and y values. And I'm going to get my graph, my t-chart, ready by switching the x and y. So again, the y's, I'm just going to use the ones I'm going to graph now, of 1, 4, and 16 become the x's of the log function, and the x's of 0, 1, and 2 become the y's of the log function. So I'm going to come over here and graph them. Here's 1, 0, 4, 1, and 2, 16 won't fit on there. So again, with only 2 points, you need to remember that exponential growth, growth in a log looks like this lowercase r. So I'm going to go ahead and take these points, and I'm going to move them all, or there's only 2 of them, to the right to 1 time. So this one will move here, and this one will move here. And then the other thing that will move is my vertical asymptote. It'll move right 1 and be right here. And now I can graph my points and go through and answer these questions. So again, for this arrow over here, x is getting bigger and bigger and bigger because it's going to the right, and the y's are going up, and there's an arrow, so they're getting bigger. And then over on this arrow, it's not going to negative infinity, it's getting closer and closer to 1, but the y's are going down as the arrow indicates, so I'll have negative infinity for y. So now for domain, my x's, I'll do 1 and infinity. Again, they'll both be parentheses because it's going to get close to 1, but it will not be 1. And the range, if you haven't figured it out, will always be this. My end behaviors, it will approach infinity, and f of x is infinity. I can see that again just by this one. And then the limit, as x approaches negative infinity, it's not approaching negative infinity, so I'll just put not applicable. So positive interval, just I'm looking at where is my graph positive and where is it negative. So as I move left to right now, let me make this a little bigger. Right here, all the y's are negative until I get to this point. And this point is 1, 0. So when I answer this, I'll be using the x values. So it's negative from 1. Sorry, that's not 1, 0. My mistake. 2, 0. It's negative from 1 to 2. So when I start to look at this, I'm using this 1 until I get to this 2. And then it switches over, and now the y's become positive. So from here to here, they're positive. So it starts being positive at 2, and then I'll put infinity for the other one. Okay, so this one has a bit more of a transformation. So I'm going to start to take a few more shortcuts here. My transformations are going to be, it's going to stretch 2. That's the 2 in front. And then it's also going to go left 2 and down 3. So this time, instead of making 2 T-charts, I'm just going to make 1 and just go ahead and already switch my X and Y. All right, so the inverse that I'll be using, again, you can just see it if you ignore all the transformations. It's right here. It's this 3 to the X. And that means B is 1, and it's growing by 3. So the X's were normally -2, -1, 0, 1, and 2. I'm going to put them here. I'm going to go ahead and make the switch all in one. And where the y-intercept was normally 1, it'll now be over an X, and then it grows by 3, or divides by 3, going the other way. And what we did in my class is we started in our T-chart and applied the stretch. So the stretch makes it go, it stretches it up or kind of compresses it down. So that affects your y values. So I'm going to make a new set of y values by multiplying these old y values over here by the stretch. So -2 is going to become -4, -1 is going to become -2, 0 is still 0, and then I get 2 and 4. Now, I will not graph these because, again, I prefer just the integer points. So, and I don't need these anymore because these are the old y. I want the new y. So I'm going to start with 1, 0, 3, 2, and 9, 4. And now I'm going to finish my transformations. I'm going to move the points left 2 and down 3. And I'm also going to, since I'm here, apply the wall. So the wall is going to be over here now. And now I'm going to take the points and move them over. So each point is going to go left 2 and down 3. So 1, 0 goes left 2, down 3. Let's see. 3, 2 will go left 2 and down 3. And 9, 4 will go left 2 and down 3. And again, this is still growth, so it looks like a lowercase r. So then I can connect my points. And for this arrow on the right, x is getting bigger, so it's infinity, and it's going up, so infinity. And on the left, it's approaching -2. It's going to get stopped by the wall. And then, but it is going down, so negative infinity. So when I do my domain, this time I'll use -2 and infinity with parentheses. Again, the range is always the infinities. My end behavior because x is approaching infinity. And when I do the other end behavior as it approaches negative infinity, again, it doesn't do that. So don't leave it empty. Please state that you realize that it's not going to happen. And this time my asymptote, my wall, is at x equals -2. All right, last one for graphing. So again, as many shortcuts as I can take now. So this one, you just need to get it graphed. So just to point out some things, it will be flipping based on the negative, right 2 and down 4. I'm going to make one T-chart, and where x was -2, -1, 0, 1, and 2, that'll be the y's. My inverse function that I'll be working with is 1/2. So again, in this, b is 1, and it's growing by 1/2. So the y's will now be the x's. So that was the y-intercept, and now it grows by 1/2. So I'm just multiplying by 1/2, which means the other way, this would have been a 2, and this would have been a 4. So now I'm going to start the transformations, and I always start with the flip, and I make a new y, and I put the flip in there, which means it's going to take all those y values and flip the top to bottom and bottom to top. So that's essentially just taking the other y's and multiplying them by a -1, or taking